Yo, 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 let's go, let's go, let's go. We're gonna do 1.09, solving quadratics with a GCF. Technically, this term, solving, we're not solving anything. What have I said a million times? When you're solving something, there's equal signs. There are not any equal signs within these quadratics, so we're gonna rename it to simplifying. Okay? We're simplifying stuff. We're not solving anything. So I don't like that term. I should just really just scrub that out because that's just not what we want to be talking about here. All right, it's simplifying quadratics. So when we're looking at this kind of stuff, we're looking at find the factors of each. Well, the factors of 18 are 1 times 18, 2 times 9, 3 times 6, 4 no, 5 no, 6 times 3, so I repeat, so I don't need that anymore. So my factors are 1, 2, 3, 6, 9, and 18. Those are my factors of 18. When I do 35, same thing, two numbers multiplied together, 1 times 35, 2 no, 3 no, 4 no, 5, yes, 5 times 7, 6 no, 7 times 5. I repeat, so I stop. So my factors are 1, 5, 7, and 35. 120 is going to take a little bit of time. It's a lot of numbers over the whole lot of stuff. So at the end of the day, we're gonna do it and then rewrite it. So I'm gonna go 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 18. No, I'm sorry, 24. I'll talk about 18. 5 times 18 is 8. Yep. No, 90. Sorry. 6 times 20, 7, no, 8 times 15, 9, no, 10 times 12, 11, no, and then 12 times 10. We repeat. So our factors are 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, and 120. Ton of factors there. That's how that works. So now we need to basically, what is a factor? I'm going to give you the clinical definition. It's a number or quantity that when multiplied. So we have a number or a quantity. Why we say a quantity? Multiplied. And the reason why we call it a quantity, let's make sure we understand that. So a number we get, these two numbers multiplied give me 18. Well, when we get deep down into this stuff, we could be using X's and Y's, Z's, M's, N's, all these types of things. So we need to be able to understand that a quantity could also be something we don't really know what it is, but it's still something, okay? Then we multiply it with another, so a number that's, or quantity that's multiplied with another number or quantity, it produces. So if it produces, remember when you multiply something together, you're getting a product. So when you multiply something together, you're getting a product. A given number or expression. Okay, so that's very clinical. At the end of the day, what we multiply together to get it. So we're pulling it apart, if you will. So factors of, say, a dollar bill. What's a factor of a dollar bill? 4 quarters, technically. I mean, you add them together, or you could say 2, but you get what I'm saying? You're pulling things apart. That's kind of what we're looking for, pulling things apart. So now it's asking us to determine GCFs and difference of squares, the greatest common factor. I will say GCF till I'm blue in the face. I'm always going to say GCF. The greatest common factor of 2 or more numbers is the largest number that is a factor of all the numbers. That's a lot of words. It gets confusing. At the end of the day, you need to know what are my greatest common factors. So if I was to look at all of these, let's take 18. Let's take 18 and 20. And I said, what's the GCF of 18 and 20? Well, you try to find out where within these sets of numbers is the largest number that they have in common. So we got 1, 2, 3, 6, 9. There's no 9, and 18. There's no 18. So the GCF for 18 and 120 is 6. That's the greatest common factor. It's the greatest common factor between the two. Okay? Cool beans. Let's keep it moving and go up to the next bad boy. Raise this up a little bit, or just kind of erase this. Clean this up. Climbing up the screen, climbing up the screen. We'll save that. So we're going to go back and then we'll say our greatest common factor. We already know this is the greatest common factor. Common factor, GCF. What's the greatest common factor of 12 and 18? So it's 1, 2, 3, 4, 6, and 12. And 1, 2, 3, 6, 9, and 18. So my GCF, these are factors of 12 and 18. What's my GCF? Well, my GCF is 6. Let's do it for 10 and 35. So I have 1, 2, 5, 10, 1, 2, 3, 1, 5, 7, and 35. GCF, 5. 8 and 30, 1, 2, 4, 8, 1, 2, 3, 5, 6, 10, 15, and 30. GCF, deuce. Without doing that, sometimes you'd think it may be 4. It's not 4, okay? So now we're going to add variables to it. Variables the same way, okay? So we already know our GCF, our number GCF for 12 and 18. We already know that from up here is 6. Now we have to determine what's the GCF of these two. Well, if you think about it, x to the 4th can be written out as x times x times x times x, and x to the 3rd can be written out as x times x times x. This is very similar. Right here we're looking for what is the GCF, or what they have in common. When you're looking for GCFs for things with exponents, you're always looking for that they have a like term, which is the x, or a like base, which is the x. So we're looking for the largest exponent. What do they have in common? Well, this has 3 and this has 3, so it would be x to the 3rd. And that would be my GCF for both. That is something that I could take out of both of them. Okay? to show you in a way that it would be totally pulled apart, we're going to do it a little bit differently here. Okay? I'm going to go ahead and just tell you that the GCF for this is 5y squared. That is the GCF. Why is it the GCF? Because what it's saying is, what are my factors, or what are the GCF? What could I do to get this out? What would be my GCF? So basically, if I factored out a 5y squared, it has to have it in it, okay? So those would basically cancel, and this would be left with 2. So this would be technically 2 times 5, or, apologize, it would be technically 5y squared times 2. If I multiply that back together, remember 2 things that multiply, that would be 10y squared. So if I do it on the other side, 5y squared, then that would cancel to 9, and this would be left with y. So now I have 5y squared and 9y. So you'll see that this and this is the GCF, because what's left, that 2 and that 9y, have 0 in common. There's nothing in common. That 5y squared is the max that is in common between the two expressions, or two little, whatever you would call those. We'll call them expressions. Okay? Let's do this one. So again, let's try it again. Let's say that I know that it's 9xy is my GCF. We did this in class, but let's say y. Y is it? So y is it, this would be 9xy. If I took it out, remember we're basically trying to pull something out. So if we pull this 9xy out, what would be left there? If we pull this 9xy out, what would be left there? Whatever is in the parentheses is what is not in common. Whatever is in the parentheses, what's left is what's not in common. So when we divide 18 divided by 9, we get 2. X squared over x, we get x, and y's cancel. So we have 2x. 27 over 9 is 3. X is canceled. Y squared over y is y. So it's 3y. So you'll see in blue, my largest thing in common is 9xy, right? 9xy is my largest thing in common, or my GCF. The 2x and 3y have 0 in common. There's no way to get to either one of those either way. So that's why we're talking about GCF. It's like, what can we take out together that we have in common? Like friends. What do you have in common with your friend? Okay? So we're going to erase here, and we're going to keep it moving a little bit longer down the road. Race, 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 race. Hopefully, some of you guys may have gotten a little bit more from that. Might have helped. I don't know. Maybe, maybe not. We'll find out. All right, let's roll, train, roll. Let's go up, and this is the last 4. Now, when we were doing this in class, again, I got this from somebody else, so wasn't quite sure what they were asking. I was kind of reading it and whatever. So finding a GCF is the first step in factoring. Factoring is what we have in common. We're pulling things out. What do we have in common is what we're doing with factoring. We're trying to pull things out so that we can previously, for instance, previously you learned how to do something like this, right? We'd say, okay, we'll multiply that. Well, you go, all right, well, that's 4x squared plus 12x, right? That's what you would do. And you would have, well, now we're giving you this and asking you to go the opposite direction and basically factor out something that's in common. That's what we're doing. We asked you to go forwards previously. Now we're asking you, factoring is almost like going backwards. You're going to where you were, if you will. Okay, so finding a factor. Factoring is a process of breaking a polynomial into its simplest factors. Remember, factors are the smallest values that can be multiplied together to give you the original. So it's what we can then put back together. Very simple as this, where we multiply this together to get this. We're going to pull it apart. And we could go back and forth with these. So these are things you can always check on. And I'll show you what I mean by that. So we're looking at 8 and 32. What's the largest factor they would have in common? Well, let's just do them real quick over here to the side. We'll have 1, 2, 4, and 8. And 1, 2, 4. And I had, no, not 4. 8, 16, yep, and 32. There we go. Yep, did those. There's my factor. 8. So we're going to pull that out, okay? We're going to like divide that out. Very similar to how you had this. Remember, we go back and we show you this one again. Multiply. So when you're distributing, you're multiplying. When you're factoring, you're going to be like dividing it out, pulling it out. So what do they have in common at 8? What does x squared and x have in common? Well, x. So it's the smallest exponent that you can take out. It's the smallest one. This is a 1 here. So these are x to the 1, x to the 1. You don't write 1, but that's what they are. Then you understand that here's my GCF. Let me write it up a little. Let me write it a little bit higher so I got a little bit more room. Here's your GCF of 8 and x. What is left? Well, that's an x and that's 4. And 8 is 1 and x is 1. So it's plus 1. Why? This is factored out. Here's my GCF. Okay? Here's my GCF. If you notice, look at that. That looks similar. If we were to go forward, we're right back to where we started. That's all we're doing is we're pulling things apart from where they were. That's all we're doing. We're pulling it back apart. So this is your final answer for that one. Very similar to this. You're pulling it apart. What's my GCF? Always, always, always the first things first. You have like bases. If this was a Q or an R, it wasn't an X, you couldn't do this. The X has to be in common. So you have to have the X. So my GCF for my first one is X, for my variable is X squared. What's my GCF for 15? Well, 15 is 1, 3, 5, and 15. Well, 25 is not divisible by 3. 25 is not divisible by 15, but 25 is divisible by 5. So that's going to be my GCF for my numbers. So my GCF comes outside. That's what they have in common. What they don't have in common stays inside. They don't have, so 5x squared and 3 have nothing in common. Hence, they stay inside. If you were wondering why this becomes x squared, it's because you simply subtract them when they're divided like that. That's how that works. Okay? Hopefully that's on the screen. Let me make sure. There it goes. There's the screen. Hopefully you see that. Cool. Kick it back. Good. All right. So let's do number 9. Number 9 looks confusing. Well, let's just start. We need to understand that we're going to have a GCF. We don't know what it is. A parentheses, because we're pulling it out. Then we have something, whatever's there, a plus sign, and then something else, and then a parentheses. If you set it up like that, it may make more sense. So we do piece by piece. Let's just do piece by piece. Okay? Let me erase a little bit of this so I have some space. Well, first and foremost, they don't have anything in common. There's no reason to even bother with them. They stay inside. They have nothing in common. They stay inside. Kill that. Then I'm looking at my x's. Well, the highest exponent is x squared. So this x squared they have in common comes out. That cancels, so that's done. This is x squared. So that goes right there. The next one we look at is y squared as my highest exponents for my y. So it's a GCF, so it comes out. What is left? y3 minus y2, if you will, is simply y. So that stays there. These two cancel. Largest exponent for my z is z. 1. Z comes out. These cancel. That's left with a z. So your final answer is x squared, y squared, z, 2x squared y plus 7z. And it may benefit you to write it like that. Write it like the red line. I'll give you that format first, and then finish it off by combining it all together. Last one, last one, last one. Let's do the variables first. Okay, so again, we're here, minus, here, plus, here, close. But let's do the variables first. Let's leave the 6, 36, and 21. But you'll notice my negative doesn't change, my positive. I'm not worried about signs here. We're just worried about what they have in common. If you look at the last one, they're all single exponents. X to the 1, y to the 1, z to the 1. So it doesn't matter what these other ones have. That's the most we can get out. That is what they all have in common. These simply cancel. That cancels, that cancels. What's left is 1y. It goes in the middle. Z's cancel, y's cancel. What's left is 1x. That goes in the front. So there's no variables here. They cancel each other out. That's what they take out. Just easy one there. What is in common? X, Y, and Z. What is left that's not in common? There's an X here, there's a Y there, and there's nothing there. Now we just got to handle our numbers. Our numbers are going to be 1, 2, 3, and 6. And sometimes it's best just to take the lowest number. Take the lowest number, because then you don't have to do like 120. You don't want to do 1,000 of those things. Take the lowest number, because this has the least amount of factors. Then you can figure it out. Well, 1, we're not worried about. Don't worry about 1. That's irrelevant. So you have to ask yourself, well, is 36, does 2 go into 36? Is the fact? Yes. Does it go into 21? No. So it's not common. Does 3 go into 36? Yes. Does 3 go into 21? 3 times 7 is 21. So that's a possibility. It's a factor of both. We don't know if it's the greatest one. We have to check 6 first. Is 6 a factor of 36? Yes. Is 6 a factor of 31? No. So our GCF is 3. So we take a 3, and a 3. 6 divided by 3 is 2. 36 divided by 3 is 12. 21 divided by 3 is 7. So our final answer is 3x, y, z. That's what they all have in common. 2x minus 12y plus 7. Now, let's make sure we're on the same page. This 2 and this 12 have something in common, but not with the 7. It has to be in common with all of them, the entirety of the whole piece. So since there's no common factor amongst all of them. This is uncommon with all three pieces. What's left? Neither of them have an x that we could pull out, or all of them have to have an x. They don't. All of them have to have a y. They don't. And all of them would have to have a common factor. They don't. If you wanted to check, this is 1 times 2, the lowest factor. So 1 is irrelevant. Is 12 divisible by 2? Yes. Is 7? No. So it can't be. So we stop there. Hopefully this helps clarify some things. See you next time.